First of all is the structural concept of the building. Okay, the structural concept developed consists of conventional foundation, cast and situ first story, which is reinforced concrete, beam and slab system, precast concrete load bearing wall, precast concrete non-load bearing fakat panel, precast concrete floor system, precast concrete beam and precast slab, precast concrete with a precast concrete slab system. First is the foundation. The foundation load for the precast structural system will be similar to those for conventional design. However, the arrangement of the foundation below the load-bearing wall will be different to those normally adapted for a column and beam structural system. In the case of footing foundation system, the recommended solution is a continuous strip footing below the load-bearing wall. Second is the ground beam and slab. While is it possible to adopt precast construction at the first story, is it considered unlikely that this will be the cost-effective or provide significant buildability advantage over the conventional beam and slab for the first story construction. This is based on the consideration that the formwork cost for construction on grade is negligible. Adapting the conventional construction for the first story has the additional advantage of providing more lead time for the production of the precast component. Third is the precast load-bearing wall. Precast load-bearing wall provide an economical solution when compared to the conventional column or beam or infill wall system. In adapting the wall thickness, the structural adequacy is not the sole consideration. Other factors to be considered include connection detail for support beam and slab, sound transmission and fire rating, joint detail, and the possible future embedded service. Fourth is the precast non-load bearing fakat panel. Typically, the wall panel for the front and rear elevation are not load bearing fakat element. Support of this panel is achieved by any of the following method, which is the fakat panel is connected to the main load bearing wall and designed to carry its own weight between support. Besides that, the fakat panel is connected to the floor, slab or beam, which is then designed to provide support to the wall. Okay, the lastly is precast floor system. Two alternate floor systems have been developed for the proposed precast system. In both systems, an in situ structural topic is adopted based on the following consideration, which is precast slab are less thickness and reduced weight. Second, different composite slab thickness can be achieved as required by structural consideration. Next, the topping concrete and reinforcement provide a simple means of tying the floor and wall component together. Okay, besides that, the service are simply provided inside within the topping concrete. The service within the bathroom and toilet floor are generally of significant diameter and required to be let to fall. In this area, it is likely that minimum topping thickness of 85 mm will be necessary to incorporate this service.
Assalamualaikum and hi to Sir Kohengbon. My name is Siti Haisal binti Muhammad Hatta and I will start present about a structural system. So the structural system of superstructure consists of precast construction of RCC wall, column, slab and beam. Floor slab should be considered to act as a rigid diagram to transfer the lateral forces to wall or column. First floor to the higher floor should be constructed by precast technology. So the first one is a precast slab. Precast slab are cast in a factory environment and include the following pre-stressed concrete option. So for example, a hollow core unit. So in this project, we're using a hollow core unit. A hollow core slab offers the ideal structural section by reducing that weight while providing the maximum structural efficiency within the slab depth. Precast floor are available with a variety of factory form, notches, slot, and reinforcement arrangement which offer various design approach. So this one is an example of hollow core slab. And next is a precast beam. Beam and beam shell are both used for suspended flooring. Beam are typically used as ledge for other form of precast flooring to sit on, but can also be used as a flooring option in their own right. They are generally manufactured to suit each particular situation, and profile can include T-beam, L-beam, and I-beam. Beam can either reinforce or pre-stresses. So next is a precast column. So precast concrete columns are modular in design in order to be made into different height. Width are 12, 80, and 24. Columns are not structural but can be used as such only after a structural engineer has adapted them to a building. Precast column can be produced as either single-story corbel column or multi-story column. Column can either be rectangular or circular in section. Projecting rebar can be provided for tying into in-situ floors. Options for foundation connection include cast-in base plate, dowel tubes, or projection. Beam support is achieved by either fair-head, cobble, or bolt-on brackets. So this one is a example of single-story column and multi-story column. So the last one is a connection. The design and construction of joint and connection is the most important consideration in precast concrete structures. The purpose is to transmit forces between structural member and or to provide stability and robustness. Within a single connection, there may be several load transmitting joint, and so it is first necessary to discuss between a joint and a connection. A joint is the action of force, for example, tension, shear, compression, that take place at the interface between two or more structural elements. So, okay, this one is the layout plan of the first floor. Okay, so this one. Okay, for our project, we propose 300 300 times 500 for beam size, and for column is 300 times 350 millimeters. So, okay, so design data in this project, we have four. First, precast floor slab, precast beam, precast column, and connection. So this is that design data for precast floor slab. Okay, so cross section area 150 millimeter square, unit of concrete 25, concrete topping and finishes 3.0, variable action 5.0, and moment of initial is 165 millimeter. And this one is a precast floor slab data. Okay, this one is a pre-stressing tendon. Okay, and this one is a design data for precast beam. This one is a design data for precast column. And this one is design data for connection.
Hi, my name is Rohaini binti Sakinam. This is the analysis and design. The design that we use is using StatePro software. It will design the widely used to analyze and design structure for building. The design was consisting precast floor slab, beam, column, and connection. It can generate a 3D influence surface based on displacement, support reaction, beam displacement, support reaction, beam force, and other for any point on the building. First is, we design the precast floor slab. Based on the calculation, we got the initial pre-stressing force, which is 920.16 kN. After that, we calculate the loss, which is creep loss, shrinkage loss, and elastic loss. From the creep loss, we got 8.50%. From the shrinkage loss, we get 4.77%. And the elastic loss, we got 4.53%. And then the total of three losses is 17.45%. And then we get the thickness of slab, which is 438 millimeter. Therefore, the pre-stressing of force was 4851 kN per m, less than P1, less than 5114 kN per meter. This is the picture of output from the software, which is, as we can see, this is the slab of floor, and this one the foundation. And this is the picture of detailing of floor slab. As you can see, we use 438 millimeter of thickness of slab. and the length of slab which is 12.20 meter. Next, we calculate the precast beam. For the precast beam, the dead load of beam for the finishes which is 1.20 kN per meter squared. For the services, we use 0.5 kN per meter squared. And then for the partition, we use 1 kN per meter squared. And the total of dead load is 2.70 kN per meter squared. And for the live load, we use 5 kN per meter squared. So the based on the calculation of UDL, we got 11.78 kN per meter squared. The beam size that we use is 300 times 500 millimeter. So after we calculate, we got the AS provided and AS prime provided. For the AS provided, we got 3080 millimeter squared. And for the AS prime provided, we got 503 millimeter squared. As we can see, this is the envelope load from dead load and live load. And then this is the detailing of precast beam. After we calculate, the top of reinforcement, we use 8T100. And then the bottom of beam, we use 12T75 and 10T50.
Hello, I am Shazwani binti Syari. Okay, so next I will proceed to precast column calculation. Okay, from the precast column calculation, okay, we decide to design the B/7 column with the size 300 times 350 millimeter. Okay, for the size of main beam, 300 times 500 millimeter, and the length of L1Y and L2Y, we use the same size, which is 12.2 meter. And for the secondary beam size, we use 300 times 500 millimeter, and for the length L1Z, we use 6.1 meter, and for the length L2Z, we use 7.6 meter. Okay, from the calculation, we calculate for the moment in Z axis, we got 7.26 kilonewton meter, and meanwhile for the moment in Y axis, we got 0 kilonewton meter. Okay, next, based on the picture, as we can see, this is the property of column that we got from the StatPro software. Okay, and this one is a detailing column with a size 300 times 300 meter. Okay, from the detailing, we can see the bar number. We use 4 bar size 12 and AS 0.50. AS required 108, FC 30 MPa, and FY 415 MPa. Okay, next we proceed to connection calculation. Okay, for flexural compressive strength, from the equation FB equal to M over Z, which is Z equal to ZT over ZB. Okay, from the calculation, we got the value which is 213.97 Newton per millimeter squared. Okay, from that, we now use equal angle with 120 times 120 times 12L with gross 2 times 2750. So we got 5500 millimeter squared. Okay, from that, we can calculate the distance of both. Okay, after we calculate, so we know the value of minimum and maximum of distance of both. Okay, so the value of minimum, which is 2.4 millimeter. Meanwhile, for the maximum value, we got 88 millimeter. Okay, so from the value, we can know the distance of both we use is bars. Okay, next, okay, based on this picture, we can see the RC column. We use 450 millimeter times 450 millimeter. Okay, and then for the precast concrete beam, the size we use 300 times 350 millimeter. Okay. So, this as we can see, this is the bolt, the position of the bolt that we place. Okay, and then this one is the steel angle. Okay, next, as we can see, this is the detailing of the connection. Okay, detailing connection between column and beam. Okay, as you can see, this is the position that we propose. And for the top beam, we use 8T10. Meanwhile, for the bottom beam, we use 12T75 plus 10T50 with the RC column size 450 times 450 millimeter.